So I'm Jeffrey Denton. I'm a systems programmer at Clemson University. Who's familiar with Hadoop? All right, that's more than I expected. Has anybody heard of OrangeFS? Great. Has anybody heard of myHadoop?
From SDSC, right?
Correct. Great. Okay. So I'm here to present using PBS and myHadoop to schedule Hadoop MapReduce jobs, accessing a persistent OrangeFS installation. So the motivation, we wanted to enable researchers at Clemson to run Hadoop MapReduce jobs in a PBS Pro scheduled environment, leveraging our existing OrangeFS installation, which I think is 64 servers at the moment. So some background. What is Apache Hadoop? The Hadoop project develops open source software for reliable, scalable, distributed computing. And you can go to hadoop.apache.org for more information. Hadoop is composed of two main projects, that's MapReduce and the distributed file system. But first, from a client perspective, clients submit a job, a processing job, in the form of a jar file to the job tracker or the master node. And from there, the job tracker writes to Hdfs that jar file so that it can be seen by these slave or worker nodes. And from there, tasks execute and attempt to read data locally from Hdfs. And data is also replicated across nodes and even across racks. So MapReduce, let's take a closer look. I'm not sure if you can see it in the back, but it's kind of the same diagram as before. A user submits the job to the master, and from there, based upon which input split is going to be processed, the worker that actually contains the input split will do processing on that data. They may have to write some intermediate data to local disk, and from there, the master then schedules reduce tasks to reduce the results down to some usable data. And in order to get that data, it has to perform a remote read from the worker that wrote the intermediate data. And then finally, data is output back to Hdfs. And that's your usable data. So, Hdfs. Here you can see clients perform metadata operations to the name node, which is essentially the metadata server of Hdfs. And it stores like the file name, the number of replicas you'd like to be stored throughout the system. Clients also read and write data locally if they can, so that it doesn't have to go over the network. And as you can see here, blocks are replicated between racks in case you lose a rack. All right, what is OrangeFS? OrangeFS is the next generation of PVFS, the Parallel Virtual File System, an open source distributed parallel file system. So basically how it works is you have multiple clients, you can have multiple clients, that read and write file data to multiple RAID arrays. And metadata can also be distributed amongst multiple OrangeFS servers and are usually stored on SSDs for improved performance. And this way you get the aggregate capabilities of all the disks throughout the servers. So some distinguishing features of OrangeFS. Like I said, it's based on PVFS. Support multiple metadata servers, so there's not a single bottleneck like with the Hadoop name node. We also support full read or full write modification anywhere within a file, whereas in Hadoop, append support has been spotty. It's not very stable as far as I know. So files are essentially immutable in Hdfs. And that's traditionally because it's a write once, read many file system. OrangeFS is written in C, and we are supporting metadata and file data replication coming in version 3.0, which is probably going to be within the next year sometime. It's open source, LGPL2, and there's paid support offered through OmniBond, which is a Clemson spinoff. Whoops. There's also an active community and developers list, and we support a diverse selection of client interfaces. As you can see here, we support Linux, Mac, Windows, and we also have these other interfaces. The direct interface is really cool. It's written in C, it's a C library, and you can take already compiled programs, say they depend on standard IO.h, and you can actually preload the library without having to recompile your program. You can leverage parallel access to OrangeFS. That's a really neat feature. We have some web interfaces and MPI I/O, and just recently Hadoop. So, Hadoop with OrangeFS. Hadoop MapReduce contains this abstract file system class. And what that enables you to do is extend that class, write your own implementation, and then in a Hadoop configuration file, set your designated file system. But Hadoop's written in Java, and OrangeFS is written in C. So in order to bridge that gap, we had to use the Java native interface, Shim, or create a Shim, which allows data to be passed between programs. So the JNI Shim, it allows Java methods to execute C functions present in the OrangeFS direct client interface. Those would be like open, close, read, write, that sort of thing. We were able to avoid the overhead of an extra memory copy between the two programming languages through the use of Java's NIO direct byte buffer. And how that works is you would allocate a buffer of some size on the Java side, and then using JNI functions on the C side, you would get the address of that buffer in memory, and there you could directly, whoa, what did I hit? Okay, there we go. And from there, the C functions can operate on that memory directly. So more on the OrangeFS direct client interface library. Like I said, it's a collection of familiar POSIX-like or standard input-output library calls designed for parallel access to OrangeFS. So there's two different storage approaches you could take. One is the traditional Hadoop model where the data servers are co-located on the same hardware as the Hadoop MapReduce clients, and then they communicate over some network. The alternate approach, usually the HPC approach, you have clients accessing a remote or dedicated storage system. And so we were interested to see if we could improve performance using this approach, since networks have gotten faster and outpaced the speed of disks, essentially. And we call this the dedicated or remote storage approach. So some benchmarks. Without getting into too much detail here, there's a really interesting article posted to HPC Wire. If you Google OrangeFS, it goes into detail about how we perform these benchmarks. But essentially, Hadoop comes with a suite of example and test programs you can run. One of those being the TerraSort suite of tests. So there's TerraGen, TerraSort, and TerraValidate. TerraGen generates a terabyte or some specified size of key value pairs, randomly generated key value pairs. Then TerraSort sorts those key value pairs using MapReduce. And afterwards, you can run TerraValidate to make sure you indeed did sort all the key value pairs. And so let's take a closer look at this. So the first dark blue data point is Hdfs with replication set to 3. I won't go too much into that data point, but as you can see, it takes slightly longer. This less is better in this graph, runtime. Here we have Hdfs with replication set to 1. This is for a fair comparison with OrangeFS, because OrangeFS doesn't support replication at the moment. Generally, OrangeFS servers run on really robust hardware with redundant power supplies and RAID 5 or RAID 6 disk arrays for parity. And as you can see, there are some differences in the TerraGen, TerraSort, and TerraValidate. But the interesting thing to note here is Hdfs with replication set to 1 and OrangeFS. This is all using the traditional Hadoop approach with co-located storage. They perform nearly identically. And we see differences here, this is probably due to the fact that Hdfs can leverage data locality. So it doesn't have to actually send any data over the network. It's just, there's a process running on the node that's going to store the data, and it's just dumping random data to disk. Whereas with OrangeFS, we do actually transfer it over the network here in this data point. So this data point right here is the remote storage approach, where we have essentially double the number of nodes involved with the MapReduce program. Let's say we had 8 storage nodes and 8 client nodes. running MapReduce. So between OrangeFS using the traditional approach and OrangeFS using this remote HPC storage approach, we see roughly a 25% improvement in overall job runtime. More on this remote or dedicated approach. This time we used 16 storage servers and started with 16 clients, remote clients, and then increased to 32, 64. And as you can see here, performance doesn't really change on TerraGen and TerraValidate because this is pretty much a straight write to the file system and this is a straight read. So the file system can only perform so quickly. But you do see a really large decrease as you double the number of clients. And this is probably due to the fact that there's less contention on the local disks during that intermediate data writing stage. You can imagine that if you have the input and output data being handled by OrangeFS, and the intermediate data is actually reading and writing on a separate set of hardware, there's less contention, and so it'll complete quicker. So what is myHadoop? myHadoop is a simple system for end users to provision Hadoop instances on traditional supercomputing resources without requiring any root privileges. Users may use myHadoop to configure and instantiate Hadoop on the fly via regular batch scripts. And there's the SourceForge project if you're interested. So how does myHadoop work? Well, there are some template configuration files, one of those being core-site.xml and the other being MapReduce.xml. Core-site is responsible for designating which node you want to be the name node, and MapReduce is used to determine which one you want to be the job tracker. So what happens is, I'll get more into the PBS node file in a second. The Hdfs site file really just contains some configuration values that overwrite the default configuration file. So myHadoop scripts. There's a set environment script. It defines required environment variables. There's the configure script and a cleanup script. Those are to prepare the configuration and the compute nodes for running MapReduce. And cleanup is pretty self-explanatory. And then there's also an example script that shows you how to use these other scripts, and you squeeze your MapReduce job in the middle. So how does the configure script work? I've recently learned that there's, I'm by no means a PBS expert. I've probably been working with it for a few months. So I've learned of the prologue and epilogue, and this could probably be updated to use those features. But here, a user requests in nodes. PBS creates the node file, which is just a list of host names where you're going to run. And like I said before, the first node is assigned as the job tracker and the name node, but it also functions as a worker node as well. So it runs the task tracker and data node daemons as well. The remaining nodes are task trackers and data nodes only. So continuing on with this, next, the default Hadoop configuration is copied to your directory where your modified configuration is going to reside. Then set is used to replace that template placeholder of master with whatever node is going to be your job tracker and name node. After that, the whole node file is then copied to the Hadoop configuration directory. And this slaves configuration file represents which nodes are going to be your task trackers and your data nodes. Then it appends desired environment variables to the Hadoop environment script so that Hadoop is aware of some specified variables. And then lastly, for all the Hadoop slaves, an SSH connection is made. Any previous log or data directories are removed, and then they're recreated for the current run. Oops. So then the user would define what Hadoop job they want to run, and then they would run the cleanup script after it completes. Basically, it just removes the data and log directories. So, customizing myHadoop for OrangeFS. Put a GitHub repository if you want to go to GitHub and search for myHadoop OrangeFS. You'll be able to see the code as it was originally and the modifications we had to support OrangeFS. So modifications to the set environment script. Basically, I was able to remove the Hadoop data directory because the data is now being stored under OrangeFS. But then there's this question of where does that intermediate data get written? It used to be written to the same directory as the Hadoop data directory. But now it's stored in this defined location. Next, we have to define the JNI library path. This is the path to the OrangeFS shared libraries and the jar files containing the OrangeFS extension for Hadoop as well as the JNI layer. So Hadoop needs to be aware of this to use it. Lastly, there's the PVFS2 tab file, which is a holdover from PVFS. And this specifies which server the client should contact initially. The reason I say initially is because the server configuration file, metadata handles and file handles are split into ranges or buckets, and they're assigned to each server. So all the client has to do to figure out where a particular piece of metadata or data resides is look at its handle, and then it'll automatically know which server has it. So it doesn't have to contact the metadata server each time to figure out where something's stored. So that's why it's just one initial contact to get the configuration information, and then it can run. Okay, so myHadoop had this persist functionality where data that was stored to Hdfs, you could configure it to persist after you wanted to tear Hdfs down. Well, OrangeFS, we're assuming, is always going to persist, so there was no reason to keep that feature around. Then I used sed to manipulate the host names received back from PBS to make a host name that appeared like this to look like this. So this is a sed in place search and replace command. So it searches for .lakeside and replaces it with -ib0.lakeside. And this is to specify to use the IP over InfiniBand interface. And I've recently learned that there's other ways to specify that you would like to use InfiniBand network connections. So I can probably remove that here in the future. And then OrangeFS related environment variables are appended to the Hadoop environment script. And here's an example of a big one that's important. So Hadoop needs to be aware that we're using additional Java packages to support this approach. And so we had to modify the Hadoop, or set the Hadoop class path to include the location of the Hadoop extension for OFS, or OrangeFS, and the OrangeFS JNI layer, since they're two separate packages. And the reason they're separate is because you might envision another Java program wanting to use OrangeFS for parallel access later on. So we created an example script customized for OrangeFS. Hadoop includes these convenience scripts dubbed start all and stop all. Now, those start all MapReduce related daemons as well as HDFS related daemons, but since we're not using HDFS, there's also a convenience script called start MapRed.sh, and all it does is start the job tracker and the job tracker and the task trackers. And like I said, there are stop scripts too. So here's a pseudocode example of what's present in the PBS OrangeFS example. So first, set environment is called to set your environment variables. Then you create your output directory for where your configuration is, your Hadoop configuration is going to reside. And then you call PBS configure. Again, that adjusts the Hadoop configuration files based on the resources you've been allocated by PBS. After that, you run the start MapRed convenience script. This starts up your job tracker and task trackers on all your compute nodes. Then you define the actual job you want to run. So word count, for example. Lastly, you run, when the job completes, you run stop MapRed to stop the job tracker and task trackers, and cleanup to remove any log or temporary data. All right, and that's it. Is there any questions?
I guess I'll ask one.
You're loud enough.
I'm loud enough. So the local OrangeFS and the remote OrangeFS, I guess I still don't understand as I understand it. It's similar to something like Cluster. It's a
Correct.
parallel file system. So then how did you do the local version? You had 2 different runs when you looked at the TerraSort.
Right. So basically, I would go and configure OrangeFS. And those architectures I talked about, you could run OrangeFS in a scheduled environment, but we didn't really test that approach. It'd be more feasible to do in version 3 since there's replication, and we would expose maybe some data locality features to be more similar to Hdfs. But yeah, you could set up OrangeFS on the same hardware that you're going to end up running MapReduce, and then you'd have the local configuration.
I was just curious why the remote configuration is so much faster. Caching?
No, it's not caching. I think it has to do with, and this is probably exaggerated in TerraSort because it's very sort intensive. It's not a straight read or write. There's some spilling to disk as things are sorted because it can't be done all in memory. So there's this large amount of intermediate data. I think actually for 1 terabyte sorting, I saw 3 terabytes of intermediate data being written to local disk. And so you can imagine if you have 8 storage servers just handling the input and the output, and then you have 8 remote clients, each with their own disks, writing intermediate data, you can imagine that there's less contention for the disks, and so things will complete quicker. Any other questions?
How long did it take you to roll this out and finding your students who are liking it or your researchers?
The OrangeFS extension to MapReduce, to Hadoop, took about a year to develop. I was the primary developer, and I had a couple grad students help me write it. And then these customizations to...
Trying to make it orange.
Yeah,
as close as we can do to orange.
Okay. So the modifications to myHadoop, I think I spent maybe a couple days on. myHadoop's really small. It's just a set of scripts and template configuration files. We actually haven't rolled it out in production yet on the Palmetto cluster, but that's something we'll do very soon. And you could also use this approach not in a scheduled environment. You could dedicate OrangeFS, and you can dedicate.
Yeah, but you wouldn't want to do that.
Right, exactly. You want to use PBS Professional to get things scheduled. So, thank you guys.
All right, thank you very much.